Good everyone, my name is Graphics. Today we will be looking at an aspect of mathematics which is called trigonometry, where we'll be analyzing the ratios of angles. Now we have some angles which are special, and those angles are angle 30, 45 and 60. These angles are special because all other angles are built upon these angles. And let's see. Now, we have 30 degree, 45 degree and 60 degree. We call them special angles. And one thing you need to know is that we want to obtain the values of a trigonometric function of these angles. Like when you say what will give you the value of cos 30, cos 45, cos 60, tan 30 and so on and so forth. So what we'll be doing here is that what? We are going to be considering an equilateral triangle that has each side 2 units and each of the angle are 60 degrees, because an equilateral triangle, all angles are what? Are equal. So this is what I'm talking about. Let's assume this is our equilateral triangle and each of the angle in between them is 60 degrees. And each side is 2 units. Are we good? Now, we know one thing is that if I cut this triangle into 2, what I am seeing in my left hand side will be what I'm seeing in my right hand side. We say they are what? They are symmetrical, right? And this is what I mean here. If you cut this into 2, this 60 here will be divided into 2, and we have here to be what? 30. And here to be what? Also 30. And my 60 degree is here. This is my 60 degree. My 60 degree is here. This is my 60 degree. Right? I will call this point where both of them meet my 90 degree. So you see that they are symmetrical. What I'm seeing in the right hand side is equal to what I'm seeing in the left hand side. So let's assume that the triangle is A, B, C. Right? This point here will be C. This point here also will be what? C. Here will be A. Here will be what? B. Are we good? Now, we said this side here is what? 2 units. Here also will be what? 2 units. This side here is 2 units. Here also will be 2 units. Well, now, since I have divided it into 2, it will be divided into, here will become 1 unit and what? 1 unit. So, it is the same triangle. It's symmetrical. So, I'll pick any side. So, let me just pick the right hand side. So, we're not considering triangle APC, I say ACP, right? So I'm considering this left hand side triangle here. So I have this side to be 2, here to be 1. This is my A, this is my P, and this is what? My C. But we don't know this vertical side here, which is what? Let me just call it Y, right? The angle here is what? 60 degree. The angle here is what? 30 degree. Now we want to get Y. So for we to get Y, we need to apply Pythagoras Theorem. We're applying Pythagoras Theorem, right? So Pythagoras Theorem is telling me that if you have a triangle, this is the longest side. It's called the hypotenuse. So it will be the hypotenuse square. So it will be 2 square, that's the hypotenuse, right? Equals to the opposite square plus the adjacent square. So here can be your opposite, here can be your opposite, here can be your adjacent, here can be your adjacent. So anyone can come first, right? Depending on the angle. So let me start. Since this is along x-axis, I will say 1 square plus what? Y square. So that is the law of Pythagoras Theorem. It says that the longest side square is equal to what? The opposite square plus the adjacent square, or the adjacent square plus the opposite square, any of the two. Is that taken? Now, what we'll do here is this. 2 square will give us 4. 1 square will give us 1. And we're left with our what? Y square. If I take my 1 to this side, I'll be having 4 minus 1. And that will become what? Y square. And 4 minus 1 will give us 3. Which is equal to what? Y square. So when my square is coming to this side, it will become a square root. So we'll be having y is equal to what? The square root of what? 3. Are we good? So what we simply do here is this. We will already know that our y now is now equals to what? Root of what? 3. I want to look for the cos, sine, and tan of the special angles here. So this is what we are going to do here. So I want to look for what? Now, considering angle 30 degree. Now I want to consider angle 30 degree. That is what? This angle here. I want to consider this angle here, right? So if I write sine 30, what will it give me? Now we know sine is gotten from the word so, and which is what? Sine of any angle will give us what? Opposite over what? Hypotenuse, right? Now since I'm considering my 30, the side my 30 is facing is my opposite, right? So we're having opposite, which is 1, all over, then the longest side, which is hypotenuse, that will be what? 2. So sine 30 will give us 1 over 2. Similarly, cos 30 will also give us, no, remember the word car. Car simply means cos of angle, let's say angle theta, is equals to what? Adjacent over what? Hypotenuse, right? So if you look at now, if here is our opposite, automatically here will become what? Our adjacent. So it will be adjacent, that is what? Root 3 all over what? Hypotenuse, the longest side, which is what? 2. Now the other one, which is what? Tan 30, because we are considering 30. From the word toa, we say tan of the angle is equals to what? Opposite over what? Adjacent. Now the opposite, like I said earlier, is where the angle is facing, which is 1, all over what? Adjacent, which is what? Root 3. This is my root 3. So this is what we're having when we start analyzing each of these angles. Now we are considering angle 30. Now what about when we consider angle 60 degree, right? We want to consider angle 60 degree. So if you are considering angle 60 degree, that means we're looking for what? Sine what? Sine 60, right? We're considering 60 degrees. So if you look at sine 60 degree, for the word so, sine theta is opposite of hypotenuse. Now because we are considering sine 60, that means the angle 60 is facing, the side 60 is facing will be my new opposite. So it will be opposite, which will be what? Root 3 all over what? Hypotenuse. The hypotenuse doesn't change, it's always fixed. That will be what? Root 3 all over what? 2. Then the next one will be what? Cos 60 degree. Now cos 60 from the word car means adjacent over hypotenuse, right? So my adjacent here is, if here we're considering 60, this is our opposite. So if here is the opposite now, here will become what? Adjacent. So we're having adjacent, which is 1, over hypotenuse, which doesn't change, and that is what? 2. Right? And the other one we're having tan 60, right? So tan 60 will give us adjacent, opposite, that is toa, opposite over what? Adjacent. Now the angle 60 is, the side 60 is facing is root 3 over what? Adjacent, which is 1. So we'll be having root 3 all over 1, and we'll be having what? Root 3. Are we good now? So this is what we're having when you consider the 30 degree and when you consider 60 degree. Now there's something that is missing here. That is our angle 45 and angle 90. Click on the subscribe button if you know you've learned from this video. Now we want to calculate for what? Angle 45. So we are going to be considering a square. We know that a square has all its sides equal. A square has what? All its sides equal. And let us say this is our square, right? Now each of the sides should be 1 unit. 1 unit, 1 unit, 1 unit. And we know very well that each of the angle in a square is 90 degree, right? So this is 90 degree, 90 degree, and what? 90 degree. Now If I apply the diagonal of a square, diagonal in a square, this way, if I cut the square diagonally, right, what I will see in the upper side of the diagonal will be equal to what I'm seeing in the lower side of the diagonal, right? So what I mean is this. I'll be seeing something like this. Right? This is 1 unit. And this is also what? 1 unit. This angle here will be what? 45 degrees. Because of what? If you divide 90 into 2, here will become 45. And here also become what? 45. Are we good? Now also the same thing will apply here to here will also become what? 45. Now we don't know what the hypotenuse here is, and we'll call it what? Let's call it Z. Is that good? So from here I can easily say this is A, B, C, and D. So I'm considering triangle what? Triangle A, B, D. So for we to get Z, we are going to apply Pythagoras Theorem. So applying Pythagoras Theorem, we'll be having, like I said earlier, the longest side square is equals to what? The opposite square plus what? The adjacent square, or the adjacent square plus the opposite square. Now my Z square will now be equals to what? 1 square is 1, 1 square is 1, then 1 plus 1 will give you what? 2. So my Z will now be the square root of what? 2. When the square comes to this side, it becomes square root. Is that taken? So now I can easily say this, that my Z, if I redraw this now like this, if I redraw this like this, the Z here is equals to what? Root 2. Here is 1, here is 1, right? So the angle here, we say it is what? 45. The angle here is 45, and here is what? 90. So if we start, we can easily look for the sine 45, which will give us what? Opposite over what? Hypotenuse, right? So this is my opposite. We have 1 because the angle is facing here, all over what? Hypotenuse, which is what? Root 2. Now since this is root 2, 1 over root 2, and the root, the radical is the denominator here, so we have to what? Rationalize it, because of what? It is irrational. So in rationalizing it, we'll say 1 over root 2 multiplied by root 2 over root 2. You multiply root 2 to the numerator and denominator. So at the long run, you'll be having root 2 all over what? Root 2 times root 2 give you root 2 square. Now we know very well that square is an enemy to the square root, so it will equate each other. So we'll be left with what? Root 2 over 2. So 1 over root 2 is giving us as what? Root 2 over what? 2. Is that taken? Then the next one will be what? Cos 45. Now cos 45 is giving me adjacent over hypotenuse. Now if this is the opposite, here will become what? The adjacent. And over what? Hypotenuse, which doesn't change. So we'll be having root 1 over what? 1 over root 2. Which is the same thing as giving what? What? Root 2 over what? 2. Then the last, which is what? Tan 45. Tan 45 will give us what? Opposite over what? Adjacent. And that will be 1 over 1, because this is the opposite and this is the adjacent. So 1 over 1 will give us what? 1. So this is how we calculate for angle 45. So we can solve questions involving ratios of angles without using calculator, and these are the values we are going to apply. So thank you very much. If you know you've learned from this video, don't forget to click on the subscribe button. Bye.